there is several part, maybe 4 or 5 part of topic 1, because this file is quite big, and then I will upload this file part by part. Now you can download the topic 1 and the first part and the second part, if I'm not mistaken. Okay, this first topic is about a function. This topic is very important because we will apply this concept. Uh, we will apply the concept, this concept of function in the other topics. Okay. Before that, let's look into the concept of and definition of the function. The first one is about domain and range. Domain and range. Okay. Before that, I if there is any disruption, or my voice is not clear, or my audio visual is not clear or not okay, uh, please let me know. Just on your mic, or you can also WhatsApp me lah. Just let me know, and then I will check how to continue this class. I hope everything is okay so far. And then if you have any question, you can ask me anytime. Just turn on your mic and ask your question. And then if you have no question, please switch off or mute your mic, because I record this session. Uh, 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 in- uh, if there is some noisy here outside there, they will affect the quality of this recording. Okay. Okay. What is the domain and range? Okay. For example, let's say we have a question defined as y equal to 3x minus 1. Y equal to 3x minus 1, for example. You can see in the note. There's one of the let's say I just take it randomly, this function. Uh, for this function, when we write a function, every function has x and y. We have symbol x here and y. Y equal to 3x minus 1. Every function, there must be x and 1. Okay, in this concept, in this context, we can call x as a input number. X is the input and y is the output. What is input? Input is something we need. We need input to produce output in the process. For example, let's say uh, 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 let's say just for in economic, let's say uh, we want to produce a handphone. We want to produce handphone. Let's say handphone is output, and then we need input. We need input related input that can be used to produce output. And then this input, what is input? Maybe labor also input, and then we have labor, and then we need maybe plastic, glass, and then we need and then technology, and then we need and so on, and all the input we need to process. So before we can get output, we need input. Input will be used to produce output. Same goes to the equation. When we're talking about equation, let's say for example y equal to 3x minus 1, there is two uh, two term here. What x will be considered as input, y will be considered as a output, and then there is x and y in term of input. We need value of x. What is x? First, we need to decide the value of x before we can calculate the value of y, before we can produce value of y, we can produce y. Okay, the second part is about a domain. Domain can be, okay, this typing error, you can delete it. Okay, there is a domain. The set of all inputs, the set of all input, or the set of number of x can be is a domain. We got I think we, is can be called uh can be called as a domain. Can be called as a domain, or we can write also the set of input number x is called a domain. It is called a domain. And then the set of all output numbers is called a range. Is called a range. Okay, that the second concept. Okay, for example, let's say uh I take we have if you refer to note, we have function y equal to 3x minus 1. Y equal to 3x minus 1. And then we know y is output, x is input. And then let's say what now I want to relate this with domain and range. Okay, domain, what is domain? Domain is the set numbers of input. The set number of input. Let's say I have the set number of input. Let's say have x could be x equal to 2, x equal to 4, x equal to 6. Okay, this is a, we can refer this as a set of x, set of input, number of input, the element of input, x equal to 2, x equal to 4, and x equal to 6. So this set is also known as a domain. It's also known as a domain. In other words, at the other side, the set, the value of y. What is y? When x equal to 2, what happened to y? When x equal to 4, what happened to y? When x equal to 6, what happened to y? What is the value of y when x equal to 2, x equal to 4, and x equal to 6? So what is the relation between y and x? Y equal to 3x minus 1. So what we should do, we just put replace x equal to 2 into the equation. So this is 3 times 2 minus 1. 3 times 2, 6. 6 minus 1 equal to 5. Oh, now we know that when x equal to 2, when the value of input is equal to 2, the value of y, the value of output is equal to 5. That's why the output. Then the next number of x, when x equal to 4, what happened to y? When x equal to 4, the value of y, we just replace the value of y. So y equal to 3 times 4 minus 1. 3 times 4 minus 1 is equal to 11. Oh, when x equal to 4, y equal to 11. Same goes when x equal to 6. Y will equal to 6 times 6, 36. Sorry, 3 times 6. 3 times 6. 6 times 6 times 6. 3 times 6 minus 1 equal to 70. Okay, when x equal to 6, y equal to 11. Now we have a set value of set value of output. This called as a range. In bahasa, we call it as a julat. In bahasa Melayu. In bahasa Melayu, we call it as julat. In English, we call it a range. Domain in bahasa also a domain. DOMI. We call it as also a domain, whether in bahasa or in English. So range for Y, domain for X. Okay, okay, this the the theoretical part, the theory of function. This is just for introduction. How in this class, for every topic we have two part of every for each topic, but theoretical part and the application part. For what I have explained just now is about the theoretical part of the function, the theory of the function. What is Y? What is X? How to calculate? How to get range? How to get domain? What is input? What is output? What is a function? For example, there's Y is equal to 3x minus 1. Okay. The second part of these books of this lecture is about the application. We want to apply this concept in economic and business, because it's a faculty economic and business. Since you are economic and faculty of economic and business student, since you are a registered FEP student, you need to know how to apply uh, the theory of economic and business by using the mathematics. How mathematics can be used to explain phenomena in economic and business. Okay, for example, let's say I would like to analyze about the revenue function. There is another one. There's a revenue is one concept is one of the concept in economic revenue function. The revenue function. Revenue function in bahasa. Okay, and I also will introduce you with a term in bahasa Melayu. At least you get something in bahasa. You know what is in English and what is in bahasa. Revenue function in bahasa Melayu. In my mother tongue language, in a Malaysian language or bahasa Melayu, our national language, uh, revenue function is called jumlah hasil. Jumlah revenue is hasil. We call it fungsi hasil. Fungsi hasil. Fungsi hasil. Fungsi hasil. Revenue function. What is revenue function? Now, in economic, since I am a economic, I am a economic lecturer. Okay, revenue function is about we can this concept can be represented by the TR equal to P times Q. P is price, PRICE. P is price. Q is quantity. What is price? Price of good. Price of good, and Q is quantity. Uh, uh, Number of good. Let's say let's say as a firm, you sell let's say phone. Sorry, just pen. Let's say we have a pen. You sell as a firm, you sell pen. Okay, let's say the price of pen is uh RM is ringgit Malaysia. In Malaysia, our national currency, we call it as RM, ringgit. Uh, Ringgit Malaysia. Let's say RM $3. RM three ringgit. RM three ringgit per pen. for each pen is sold at 3 ringgit. And then if you sell this pen, let's say the quantity sold, let's say you manage to sell the quantity is 10. So what is your total revenue? Total revenue is equal to PQ equal to uh 3 times 10 equal to RM 30 ringgit. That is the total revenue. The basic concept of total revenue. Okay, again, if you have any question, just let me know. Just turn on your mic and ask your question. Okay. Beside that, we can also total revenue function can also be written in a function as a function. Let's say TR, for example, TR, what is TR? TR is equal to P times Q. That's correct. But now I would like to share with you how to, the amount of TR is subject to the two element P and Q. Since P is fixed, we consider P is fixed. Q is variable. Then the value of Q can be 10, 11, or as long as Q must be positive. Q must be positive. They can take any value, number or quantity. Today, maybe you sell 10 pens, and then tomorrow maybe 50. Next week maybe 100, and so on. But P we assume it as a constant. So TR is a function of Q. The value of TR is depend on the number of Q. Let's say in function we call TR is equal to 100 Q minus Q squared. Let's say this for example. Just for example, I want to explain about how to apply the concept. Let's say TR is equal to 100 Q minus Q squared. TR equal to 100 Q minus Q squared. So this in terms of function. Now TR is function of Q. Okay, what is our function? Y equal to, for example, 3x minus 1. In general, we say y equal to mx minus y equal to mx minus 1. In general, y2 equal to mx minus 1 in general. So now, based on this theory, we can identify this equation. TR is a output. Q is a input. Because TR is at the left hand side of the equation, and Q is the right hand side. Right side of the equation. So TR is output, Q is input. So in order to get to know the value of TR, we need to decide what is Q. We need to find the value of Q. That's why the value of TR is depend on the value of the quantity. So what is the question? Okay, if you refer to the note, if you refer to my note, the question is okay, this one. Example 1.2. Example 1.2. Suppose the revenue function of the firm is TR equal to 100 Q minus Q squared, where TR is a total revenue and Q is the quantity of sale. Specify the range of revenue function if the the maximum limit of sale per month is only 50 units. In other words, the maximum limit of sale, maximum quantity is not less than 50. It's not less than 50. In economic, you must remember that in economic, quantity must be positive. The value of quantity never negative, cannot be negative. So, since this question set the maximum value of quantity is 50, so we understood that therefore the value of Q in this case must be between 0 and 50. Must be between 0 and 50. That's how to apply the theory in this case. Uh, so because quantity must be positive. No, there is no quantity. Let's say you produce a handphone car. You say your quantity is negative 10. Your quantity is negative 1000. What does it mean? There is no value here. We just must ignore the negative value of quantity. Quantity must be must be positive. Quantity must be positive. Okay. So the question asks, the question is about the range of linear function, and now we know the value of Q. The value of Q. The value of Q must be positive and not greater than 50. The value of Q is between Q and 50. This is the domain actually. Since Q is what is Q? Q is quantity. Q is input. Now the value of input must be between 0 and 50. So we know now we know about the domain. So we need to set uh, the to set the value of the range, the value of output based on this domain. Okay, how to calculate? Okay, now I will show you how to calculate the range of this by using this concept, this domain. Okay, let's go back to my whiteboard. Okay, now we have again TR. I write again here. TR is equal to 100 Q minus Q squared. And then we have a domain. Q is between 0 and 50. So what is range? Range means that what is the value of TR? TR must be also between, let's say, A and B. A is a minimum value. B must be a maximum value of TR subject to the domain. Subject to domain. Subject to this one. This domain. Okay, now we just, when Q equal to 0, the minimum value, and Q equal to 50. What happened to TR? TR equal to 100 times 0 minus 0 squared equal to 0. And then the next one, when Q equal to 50, TR equal to 100 minus 50 minus 50 squared. Okay, please use your calculator to calculate this value. We get 200 and 2,500. Okay, make sure you have a scientific calculator. You have scientific in the class. You need this that calculator to calculate the value. You are allowed to bring in the calculator in exam or in a lecture. So now we can conclude that when Q equal to 0, TR equal to 0. When Q equal to 50, TR equal to 2,500. So that means therefore we can conclude that therefore TR, the range is between 0 and 2,500. Okay, this is also known as a range. Okay, where is my note? Okay, the other part I will leave it to you, function and relationship. I hope you can read it by yourself. And then if you have any question, you can you can ask me. Okay, I will continue to how to represent this function. Okay. Uh, th- there is a few term here. I will focus on the coordinate plane or coordinate point. Coordinate term or coordinate point. Okay, when we're talking about coordinate, coordinate is very important in equation. Every equation has a coordinate. Since we have a value of x and value of x and y. Okay, what is coordinate? Coordinate must be written like this. There is in bracket. There are two value here. The first value is for input. The second value is for output. The first value is for range, sorry, domain, and the second value in the bracket is for y. Okay, for example, if we go back to this uh which my okay, we go to this concept. Okay, for the previous example, let's say we have a range uh x equal to 2, y equal to 5, x equal to 4, y equal to 11, x equal to 6, y equal to 17. In terms of coordinate, we can write this as x equal to 2, y equal to 5. The second coordinate is when x equal to 4, y equal to 11. And the last one is when x equal to 6, y equal to 70. That is a coordinate point. Okay. 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 The coordinate point can also be plot in a graph. For example, we have this graph, this axis. We have a x-axis here. This the horizontal line is for x for input. Uh, the vertical point is for output y. When we draw a line like this. For example, when I draw this graph, this for x, this for y. For input and for output. The vertical line is for y. The horizontal line is for x. And then we can plot the coordinate. For example, this one. We can plot the coordinate by refer to the point on the every line. And for example, this at this point maybe we have a -10 for x and also -5 for y. For example, that's how we plot the coordinate. Okay, any questions so far? I hope everything is clear.
No question, Professor.
Okay, thank you. I hope everything is okay. And this okay now we also can go to the this equation. I will explain later. I leave it to you for your explanation. And what is equation, what is a relation, I also leave it to you. I would like to, okay, there's the general form. How to write a function. It's very basic. When, for example, uh, uh, we can also write, let's say we have y equal to 3x minus 1. This also can be written as fx equal to 3x minus 1. This the same thing. Sometimes we can use y, sometimes we can use fx, the value of y, then the value of fx. And then when we write this as let's say we have f3, f in bracket 3. That means that we need to replace the value of x equal to 3 in the equation. For example, let's say I have uh, uh, this uh, example. I refer to this example. Let's say I would like to uh, write like this: fx equal to 3x minus 1. Now we know that x equal to 2 can also written as f2. f2 equal to 5. f4, when x equal to 5, y equal to 11. f5, f6, when x equal to 6, y equal to x equal to 6, y equal to 70. Okay, this about the fx. How to write the fx. That's the way how to write the function. There are few way here. Whether we use f, g. This also mean that we can also write this as this also equal h x equal to 3x minus 1. This the symbol of the function. In the class, I will use several of them to show the differentiate between function. Okay, to get the value. Okay, now. Okay, go back here. I will like before this, as when I explain this part, the first thing I have mentioned is about the input and output. Again, it's about input and output. Okay, what is input again? Input is x, y is output. We need input to produce output. We need input to get the value of the value of x. So in other words, the value of the value of y is depend on the value of x. Uh, in order to know the value of y, we need to decide what is the value of x. It's not just simply you write y equal to something blah blah blah, but we need to decide what is the value of x. In other, what we can see here, what we can conclude here is the value of y is depend to the value of x. That is another part we need to consider here. So in other words, we can conclude that beside input and output, domain and range, we can also conclude that when x is actually dependent, x is a dependent. The value of y is depend on x. So y is also known as a dependent variable. Meanwhile, the value of x is also known as a independent, because the value of x is will decide what is the value of y. So the value of x is uh, one, is also known as independent. So you dependent variable again. So independent variable in bahasa we call it pemboleh ubah, bebas. Dependent variable in bahasa we call it pemboleh ubah, pemboleh ubah sorry, okay, pemboleh ubah tidak bebas. Pemboleh ubah bebas and pemboleh ubah tidak bebas in bahasa. Dependent and independent variable. Okay, okay, that's a basic concept about the function. Okay, okay, in the question, the dependent. Okay, that's all I think about this concept. Okay, please refer to example 1.7. Please refer to example 1.7. Okay, in this case, I will show you uh, how to read this graph, this kind of graph, because we have we can see there are three point here, three dot, point A. Let's say there is a point A, point B, and point C. Point A, point B, and point C. Okay, at point E, okay, what does it mean? Okay, uh, there's a structural equation. When y equal to 2, when y equal to 2, y equal to 2, sorry, y equal to 2 if x is greater than 1. Y equal to 2 if x greater than 1. If x greater than 1, when x equal a minute here. Okay, again, when y equal to 2, okay, at this point, when x is greater than 1. When x greater than 1, meaning that when x equal to 1.1 and above, 2, 3, and so, the value of y is equal to 2. But when x equal to 1, when x equal to 1, 1 will equal to 0. But if x is less than 1, x equal to 0, x equal to -1, and so on, what happened to y? The value of y equal to negative 2. The value of y is equal to negative -2. So we can draw this kind of line. Okay, please let me know if you have any question here. Okay, okay, and then if you draw this picture, this function, we have 3 points here, A, B, and C. Okay, if you look at this picture, there are 3 dots here. There are 3 dots here, A, B, and A, B, and C. Okay, they are at point A. There is a hollow dot, or we call it hollow dot, or white point, white point. At point B, there is a black dot, black point. And at point C, there is another hollow dot, or white point. So what does that mean by hollow dot and black dot? Okay, at hollow dot, this one at white point, at point A and point C, the value of the function, the value of y is not defined at that point. The value of y is not defined at that point, because if we refer to this equation, okay, at point A, there is a coordinate point x equal to 1, y equal to 2. There is another, of course, there is at point B, of course, there are coordinate point. At point B, when x equal to 1, y equal to 0, and then at point C, when x equal to -2, y equal to uh, let's see, x equal to -2. Sorry, x equal to -1. X equal to 1. Sorry, x equal to 1, y equal to -2. But if you refer to the function, when equal to 1, the value of y exists at point B. At this point, y equal to 0. Okay, since we have A, B, and C, the exist point is also called point C. This point does not exist. The point C also does not exist. That how the difference between black point and white point. We will see this case again at the topic 5 or 6, if I'm not mistaken. That's how we with we uh, we uh, we determine what is white dot or black dot. White dot show that the value of y, the value of your whatever, the value of the y, the value of the range, the value of the input does not exist. It's not 0, but does not exist. Whether for example, at point A and point B, the value of y does not exist there. The value of y also exists at point B. That is where x equal to 1, x equal to 1, y equal to 0. Okay, that's all so far for this part. And then the other part, the rest of this part, I will leave it to you. You must read what is polynomial and so on. Basically, polynomial is degree 1 is called a linear function. Linear function is also called a polynomial, but polynomials uh, uh, of degree 1. Polynomial of degree 2 is called quadratic polynomial. Again, we will learn about this quadratic uh, quadratic polynomial. How to interpret the quadratic polynomial. And then polynomial of degree 3 is called a cubic. It's called a cubic. Let's say in term of linear, there is a y equal to mx campur c. Maybe this one in term of quadratic, this is equal to polynomial of degree 2 is called quadratic. Let's say y equal to x squared. For example, polynomial of degree there is called a quadratic. Polynomial of degree 3, for example, y equal to x squared plus x plus 3 x plus x kosong satu. Okay, that's all about the part one of the part one of topic one function. Any question?
No question, doctor.
Okay, now I will okay, I will proceed uh, to the second part of this text of this topic. Please refer to the topic one function part 2, linear. What is a linear? The first function we have I will explain is about the is linear function. Okay, what is a linear function? Okay, what is a linear function? Uh, but in general, the linear function, you can even note, in general, the linear function we can be written as y equal to uh, fx or fx equal to mx plus mx plus c. That is a general form of linear function. Okay. When we write a linear function, we must know the general form of linear function is y equal to mx plus c. Okay. Again, we know y is input. Sorry, y is output. X is input again. Or set of output is also a range. Set of input is also a domain. Okay. And then what is M? What is C? What is M? What is C? Okay, in this concept, M is equal to gradient or slope. In bahasa, we call it as keturunan. There is a slope. And C, what is C? C is, we call it as an intercept. In this case, the value of M must not equal to 0. That's the condition. The value of M must not equal to 0. And the value of M and C, okay, M and C are real number. M and C are real number. What is real number? What is real mother? Real number. Real number. Okay. M and C. M must not equal 0, and M and C are real number. Okay. What is real number actually? What is real number? Anyone can help me? Anyone can explain? What is real number? Anyone know what is a real number? Just try, please. Someone. There is 26 students here. Anybody know what is a real number? In a linear equation, M and C must be linear number. Anyone? Just try. No one know. No one. All.
I think it should be a rational number.
Rational number.
Yeah.
No. Rational number is a part of real number.
Okay.
Okay. Rational number is part of real number. Okay. Real number, in other words, there is M and C, and M and C can take any number from negative infinity to positive infinity. Rational number is part of real number. It's part of real number. We got integer, we got positive, negative, rational, irrational number. Okay. Thank you for your response. Okay, so in other words, the value of M in a linear equation, the value of M and C can be negative, can be positive, can be rational, can be irrational, can be negative integer, positive integer, or 0. But M must not equal to 0. C can be 0, but the value of M must not equal to 0. If M equal to 0, it means that the value of is M equal to 0, meaning that the value is not valid. The value of M is not valid. So be careful. This also this linear function y equal to mx plus c is also known as a variable is also known as a polynomial function of degree 1. And then when a linear function is drawn, when we draw the linear function, it will produce the straight line that intersect the y-axis and y-axis and the gradient. So in general, when we draw a graph for this function, for example, this just for example, let's say this horizontal is x, vertical is y, for y. When we draw a linear function, when we draw a linear function, we will get the straight line like this. For example, let's say y equal to mx plus c. In this case, m is positive. And then the second one, let's say m is negative. Let's say we have another function, y equal to mx plus c, but at this time, m must be negative. Like the linear function. But when m equal to 0, but the value of m, the condition is m must not equal to 0. Why? Because if the value of m equal to 0, let's say what is linear function? Y equal to mx plus c. When m equal to 0, what happened to this function? Y equal to 0 x plus c, y equal to c. M disappear. This value does not have m, because m equal to 0. So when m equal to 0, the function is not a linear function anymore. The function this function now become a Mala function, or uh, this function is not a linear function. The function, we can say it as a constant or monomial function when m equal to 0. And when m equal to 0. For example, when y equal to 20, uh, when the value of x increase or decrease, the value of y is consistent at uh, at for example, at this point, the value of y is consistent at point y equal to 20. It doesn't matter when the value of x increase or not. But in economic, this constant function is known as a fixed cost function. We can apply in a fixed cost function where fixed costs are the costs that have to be incurred even if the output is 0. When the output is 0, there is some cost that firm have to be paid by firm. For example, the cost of the building, wind of the building, and so on. They also uh, related to the fixed cost. Okay, I think that's all for today. I will continue this example 111 at week 5 in our next class. Okay, today is 2027. Today is 27. Next week is a public holiday, no class next week, and then we will continue our lecture at 10 April. 10 April 2025. I will continue this page 10, still about the linear function. I think that's all for today. Any question? If you like to ask any question related to this course, you will ask me now. Any question? Otherwise, we will end this section. Okay. No question. Any question? Do you?
No question.
Oh, no question. Okay, thank you, dear. Okay, if so since there is no question, I think I would like to end our lecture today. I will continue the our we I will continue the lecture for I take note here at page 10 at in next 2 week lah. Next week we have to have class at on Thursday 10 April in physical we will open the physical class for you at BS I think BS 40 if not mistaken. Okay, the further information I will share with you at the WhatsApp group. and and then for student for those who want to change who register for the other side, or you want to move to the other side, it's okay, it's up to you. But I just want you to know you can leave my WhatsApp group as soon as possible if you drop this course or when you change your set for to the other set. If you stay here, it's okay. We will see in next 2 weeks. Okay, that's all for today. Uh, Again, good morning. In bahasa we call it selamat pagi. Jumpa lagi. See you later. And happy holiday. Selamat bercuti.
Thank you, Doctor.
Welcome.
Bye bye.
Bye bye. See you next 2 week.
Terima kasih, Dokter.
Okay, just wait. Don't leave. Don't leave this session. I would like to record your attendance. I will press the end meeting button, and then you will be removed automatically. So at the same time, your attendance will be recorded by Teams. Okay, that's all.